Hello everyone, welcome to my channel. So now we are going to do Leetcode line 75 list. Another question. Find minimum n rotated sorted array. So let us first read this question, then about the constraint, then try run according to the example, then about the brute force solution, and then finally the optimized version. So now let us go ahead with the question reading. Hmm. So here, okay. So suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, the array nums which is from 0 to 7 sorted order might become 4, 5, 6, 7 increasing order, right? But 7 is that point after which 0 comes, means the smaller element comes, and then after that again it is in increasing order. Basically, it is rotated 4 times, so that's why now it is like this. So presently, even if about this explanation, we are not bothered about it how many times it has been rotated. We are just bothered about that fact that at what point we can get the element which is the smallest of all the elements being given to us in this array. So that's the main question. Then notice that rotating an array of a of 0 up till this one time may result in this. Right. So, given the sorted rotated array nums of unique elements, return the minimum elements of this array. Minimum element, not elements. You must write an algorithm that run in order of log n time. So basically, in the question only, they have mentioned that we are required to write this algorithm in order of log n time, not the order of n. Because order of n, we can easily check that just check for that particular number, which is just smaller than the any number which was there previously. So that would be order of n. But they just want us to write in order of log n. Excuse me. And that would be the most optimized solution for this particular question. Now let us first check for the constraint. Then we will be going ahead with the dry run of the solution. Sorry, addition and then decoding that. So here n equals term dot length. N is in between 1 to 5,000 means basically at max 5,000 elements could be there, and each number could vary from minus 5,000 to 5,000. That means there would be negative numbers as well, and all the integers of number are unique. Means basically it is strictly increasing, and nums is sorted and rotated between 1 and n times. Basically, it could be rotated one time also, and it could be rotated 5,000 times as well. If the maximum length input which is being given to us is 5,000. So now let us go. Let us check for the examples which are being given to us. Then we will be going ahead with the solution part. So here the number which is input which is being given to us 34512, right? So for this particular, if we check this 3, then 4, then 5, then 1 is that number which is the smallest of all. In order of n, we can directly do just like this. The way I have done means basically just checking in the for loop that whenever we encounter this particular thing, then we are required to return nums of I. Else we will be returning nums of 0. That simply means either it is rotated 0 times or nums dot size times. So that's the scenario here. So this is the brute force solution in order of n. But now comes the part that how we can do this particular solution in log n time. So for doing log n time, the thing is, it is already sorted, right? So that's why we can directly use binary search on the same. And binary search solution will give us log n solution. Now comes the part that how binary search will work on the same. So here we are required because while doing binary search, we will be dividing this particular array into two parts, right? 3, 4, 5 and 1, 2, or 3, 4 and 5, 1, 2, right? So while we have divided, So now we will be checking for the fact that is the middle element which is there, if the middle element and the middle minus one element. If see, here the middle element is 5. If middle element or middle minus one element, if middle minus one element which is there means nums of middle minus one, if it is basically greater than my this, right? That simply means that my this middle element is my answer. If that is not the scenario, means it is less than. So basically, I will be required to move ahead. Means I don't need to do anything here. Then comes the part that if my middle element and whatever is there at the right, either at this point or this point, if my middle element is basically greater than my rightmost element or any right element, then that simply means that I am required to traverse in my rightmost portion of the array. Because of this fact only, we will be able to figure out which is the smallest element. Or if other scenario is there, is other way around if somehow my left element is basically greater than my middle element, that simply means that my answer um yeah, that simply means my answer would be in my leftmost array because here it is greater and here middle is the smaller element, right? So that simply means it will lie somewhere here only. So these are the three factors which we are required to check so that we can easily able to get our final answer in log n time. So that's the scenario here. If you were not able to understand, just pause and repeat this particular portion of the video. You will be able to understand, or let me write it again only. See, if the array is something like this is a middle element, right? So, first scenario would be if my nums of 5 means if my nums of mid minus 1 is basically greater than nums of mid. That simply means that if at any point, if my middle is at this point and my this point is mid minus 1, right? If at any point this is the scenario, then in that situation, what we are required to do is we are required to directly return nums of mid because here clearly we can see this is the smallest element. So that's the thing. Then second condition is that if at any point my let us say that our mid is at this point only and my right is at this point. So here if we see that if my nums of mid is basically greater than nums of right. If this is a scenario means nums of mid is basically greater than nums of right. If that is the scenario which we can clearly see here, then what we are required to do is then at that point we will be making our left pointer left equals to mid plus 1. That simply means that now our sub array would be this point means our left pointer would be here and our middle would be at this point. After doing that, mid is equal to left plus right by 2. That's it. And our right pointer is already at this point. That simply means that if this is the case, means this case is there, then in that scenario, we are required to check for our right array, means right subarray, because the element would be there in our right subarray. So that's the thing which we are required to do here. And now the third case which was there, which I was saying, for that let me take another example because we can't see that third case in this scenario. So for third case, if we say like we are having 3, 4, 5 and our array starts from uh, please let us take our Mm, let us take this only. 6, 7 means it is somehow like this only. And our middle element is this, right? And if we check this left point, right? And if we check this mid. So now here if we compare both of them, then what we see? We see that left is basically less than mid, right? So that's why now we are required to traverse our right towards this point only. Means now our right would be equals to mid minus 1. So that we can clearly get us this answer. So that's the scenario here. So basically these are the 3 points. Means this would be covered in our L scenario only. That now we are required to make our right equals to mid minus 1. I don't know why it is lagging, but that's the thing. So that's the scenario here. Now let us go ahead for the coding part for the same for log n solution. So this is our log n solution. Minute. So here, just find minimum which is being given to us. Now we are first checking that if a nums dot size equal to 1 or if a nums of 0 is less than nums of num dot size minus 1. If that is a scenario, that simply means that if our array is of size 1, then also we are required to return nums of 0. That would be the only element as the minimum element. Or if the scenario is that nums of 0 is basically less than the endmost element which is there, is this particular case which was there, is this one 3, 4, 6, 7. Here we can clearly see that this is the smallest element, right? So at this point, this particular condition is satisfied. So we will be returning directly this. So these are the edge cases which we will be directly checking at the start only. So now, next what we are required to do, now we are going to do the binary search. So what we are doing here is we are just initializing left equal to 0 and right equals to num dot size minus 1, right? So now this is the while loop for the same. So in this particular while loop, what we are required to do is here we are just keeping check that if while left is less than equal to right so that they don't overlap each other. And now we are going to do the binary search on the same. So here for doing the binary search, first we are doing this part that middle equals to left plus right minus left. Right 2 was also there. I don't know why I missed it. Yeah. So, okay. Yeah. I basically commented this. I don't know why I commented. Okay. And then if mid is greater than 0 and nums of mid minus 1 is greater than nums of mid. So this is that case only when our middle element which is there, if that is smaller than the mid minus 1 element, and even our middle should be greater than 0. This is what we why we are checking just for this thing, as it will show runtime error, right? So that's the thing. If that is the scenario, then we will be returning nums of mid. So that's the point. And then there is one more situation that if nums of mid is greater than nums of right, that also I've explained that if my last element which was there, if that is smaller than my middle element, then I am required to check for that rightmost half of my array. So at that point, I will be making my left pointer equals to mid plus 1. And then at the end, if that is not the scenario, if other way around it is there, then I will be making my right equals to mid minus 1. So this is the thing here. And this will help us to search in the left space of our array. And then at the end, we are required to return int min. And why we are required to return int min at the end is just because of the fact that we were not able to figure out that what is the minimum element out of all of these. But in integers, the minimum element is int min itself. So that's why we are returning int min. So that's the whole scenario here. And this solution is clearly log of n because here we are not making them, means basically we are not again making them into that n space. We're just figuring out with that one element. So because of figuring out that one element, Here the time complexity is log of n rather than n log of n. So, and even here we are not using any extra space. That's why solution is of order of one space complexity. So this was all for this particular question. If you have any doubt, you could comment that down, and even with the timestamp of that particular portion so that I can explain you in the comment itself. So this was all. Thank you.